Today we're looking at section 7.3, and more specifically, we're just looking at solving systems or linear systems by combinations. Another way combinations is called, sometimes it's called elimination. We have a couple of goals using linear combinations to solve a system, and we're modeling a real life problem using linear equations. First thing you got is a definition of a linear combination. Linear combination of two equations is an equation obtained by adding one of the equations or a multiple of one of the equations, that's key right there, to the other equation. I don't like using this word adding right here, because adding implies that you're using plus or positive numbers. Think more about it as combining two things. Like you can combine -2 -3. But you would never say that you're adding those numbers. You would say I'm subtracting those numbers. However, you can combine them, -2 and -3, you know would give you -5. When we're using linear combinations, think of addition and subtraction as the same thing. Think of them as combining positive and negative numbers. Okay, in the textbook, it's not on your sheet, there's a list of steps, numbers 1 through 5. The first one is arrange the equations with like terms in columns. That means if in one equation it says x plus y equals 6, and in the other equation it says y plus x equals 7, you want them to be in columns with each other. So you either want to move the top x over to make it be the second term to where it's even here as the second part, or you want to move the bottom y over, or vice versa. You want to make sure they're stacked in columns. The second step is to multiply one or both of them, and it gets a little bit tougher when you have to do both of them, but not anything ridiculous. To make sure you have opposite terms. Remember, opposite terms are not flipping not flipping them and using the reciprocal. Opposite terms just means you want one of them to say 2x and the other one to say -2x. Those would be opposite terms. We can combine them in order to eliminate them. Number 3 says add the equations, and again, that's that word right there, add. I would prefer you say combine the equations from step 2, either positive and negative numbers. One has to be positive and the other negative because you have to combine them to eliminate one of the variables. And then once you have one of the variables eliminated, you're going to solve for the remaining variable. I'm going to show you how that looks in just a second. And then once you have that value, say x equals 4, now you have a value, x equals 4. Then you use a substitution method that we learned last week. Just plug that back into one of the original equations to get y's value. And then check them to make sure they work for both of them. Here's example number 1. It says solve the linear equation 7x plus 2y equals -6. 5x minus 2y equals -6. Again, equals +6. Again, check and make sure they're in columns. You can clearly see that x is on top of x and y is on top of y, and your constant terms are on top of your constant terms. That's clear. That has to be the case. You have to change it, you have to move it if that's not the case. Once that happens, draw yourself a line underneath them. You can see that that's what they have there. Then combine the terms. Combine 7x and 5x, and you're going to get 12x. So if I'm going to write it out here on the side, it'll look a little bit more like this to you. Plus 2y equals -6, and the other one says 5x minus 2y equals +6. Draw a line underneath the both of them. Combine your 7 and 5x and get 12x. Combine your 2y and -2y, and you have 0y, which eliminates it. That's the goal, is to eliminate it. And then combine -6 and +6, and you get 0. So that's what they have on this next line. It says 12x equals 0 because you eliminated y. Once you have that, you're going to solve for x. That says 12x equals 0. When you divide by 12, 0 divided by anything, that's where we get x equals 0. So you solved for one of the variables. Now it turns into a substitution problem. Take that value x equals 0 and plug it back into one of the first equations. They chose this equation 7x plus 2y equals negative 6. So we're just subbing in 0 for x to solve for y. Anything times 0 in this case, 7 times 0 is going to be 0 plus 2y equals negative 6. But the fact that it turns into 0 right now is just a coincidence. That won't happen every time. So that gives you 0 plus 2y equals negative 6. Just to show the intermediary step equals negative 6. Then this eliminates itself, so you have 2y equals negative 6. And when you divide by 2 on both sides, that's where we get y's value. You get y equals negative 3. So you have x's value is 0 and y's value is negative 3. So check that 0, negative 3 works by plugging in or substituting 0 in place of x and negative 3 for y. So your solution is x comma y 0 comma negative 3. In the margin, copy down this problem. You're going to do it just like the one we just did. Should be really easy. Go back through the steps. Make sure they're stacked in columns. They're stacked in columns. Draw a line underneath them. Combine the terms. Solve for the variable that's still there. When you get that value, plug it in to solve for the other one. Again, they are stacked on top of each other. X is on top of x, y is on top of y, and your constant terms, in this case, negative 8 and negative 16, are stacked on top of each other. Draw a line underneath them. Combine your terms. Negative x and positive x leaves you with no more x's, 0x. I just draw a line. You don't have to draw that line. I'm just showing it as a placeholder. 2y and 6y gives you a positive 8y. Equals comes next, and then negative 8 and negative 16 gives you negative 24. Now what we did is we eliminated the x variable. So all we have is a simple one-step equation. 8y equals negative 24. Divide by 8 on both sides, and y equals a negative divided by positive. Opposite signs is always negative. 24 divided by 8 is 3. So you have a value for y. It equals negative 3. Plug or substitute that one back into one of the other equations. It does not matter which one you choose. I'm going to go with the first one since they look the same. Negative x plus 2 times our new value for y, which we know is negative 3, equals negative 8, and simplify for x. Positive times negative is negative 6, so we have negative x minus 6 equals negative 8. Undo your order of operations by adding 6. And you have negative x equals negative 2, and then get rid of multiply by negative 1 by dividing by negative 1. And a negative divided by negative, x's value is positive 2. So you have x comma y written as 2 comma negative 3. Don't do all of that work to get those values and then write them in the wrong order. Make sure you put x and then y. 2, negative 3. Example number 2 says solve this system. 3x minus 5y equals 15 and 2x plus 4y equals negative 1. Okay, they're set up nicely as far as columns go. The x is on top, the x's, y's on top, the y's, constants on top, the constants. But if you look at the coefficients, unlike example number 1, you don't have any opposite terms here. So you have to multiply either one of the equations or both of them in order to create opposite terms. So we have to look at our factors of 3 and 2, or our multiples of 3 and 2, I should say. What that means is 3, 6, 9, 12, so on and so forth, and your multiples of 2. 2, 4, 6, 8. They both have 6. The least common multiple would be 6. So we have to multiply both of these equations to create 6, or we have to go with our factors of 5 and 4, and they don't share a term until they get to 20. We would have to make one positive and one negative 20. It says the equations are already arranged. That's what I just said. You can get the coefficients to be x by multiplying the first equation by 2. And the reason you multiply that first equation by 2 is because you want to create 6x. But you can't just make it say 6x. You have to multiply it by that term to get the one you want, but you also have to distribute it to everything else. That's why we did that on the bell word. 2 times negative 5y is negative 10y, and 2 times 15 equals 30. So that's multiplying that first equation by 2. We want to create the opposite of 6x in the bottom equation. So it says 2x, so you ask yourself, what do I have to multiply 2x by to get the opposite of 6x? And the answer is negative 3. But again, you have to multiply everything by negative 3, not just 2x. Negative 3 times 2x is negative 6x. Negative 3 times 4y is minus 12y. And negative 3 times negative 1 is positive 3. So it gives you two equations. They're still stacked on x's on top of x's, y's on top of y's, constants on top of constants. But now what you have is two opposite terms, 6x and negative 6x. That's the goal. Once they're in that form, you can eliminate them when you combine them. 6x and negative 6x leaves you with no more x's. Negative 12y and negative 10y together is negative 22y. And then 30 and 3 together is 33. So you have negative 22y and positive equals 33. Solve for y by dividing by negative 22. We're just going to be able to reduce that fraction. We're not going to be able to get an integer. It's going to be negative 3 over 2 is your value for y, or which is the same thing as negative 1.5. Negative 3 over 2. They have it written as a decimal. So now that you have your value of one of the variables, in this case y is negative, we use 1.5 since that's what they have here. Take that value, negative 1.5, and substitute it back into one of the equations. So substitute negative 1.5 for y in order to solve for x. They use the equation 2x plus 4y equals negative 1. So where it says y's value, you're just plugging in negative 1.5. 2x plus 4 times negative 1.5. Positive 4 times a negative 1.5 is going to be a negative, and 1.5 times 4 is going to be 6. So 2x, now you have minus 6 equals negative 1. Undo your order of operations by adding 6 to both sides. I'll show that step. It says 2x minus 6 equals negative 1. Add 6 to both sides, and you get 2x equals positive 5. And then when you divide both sides by 2, it's just saying 5 divided by 2, you get 2.5. So x equals 2.5. So x comma y, 2.5 or 2.5 comma negative 1.5. And the margin do this one. Again, it's set up nicely as far as the columns go. Now you want to make opposite terms with 5 and 2x, or negative 4 and 8y. Okay, so as we look at this problem, you're going to either want to get opposite terms here out of 5 and 2. When you count multiples of them, 5, 10, 15, 20, the first one they come to that they both share is 10. So we'd have to make 5x into 10x, and we'd have to make 2x into 10x, and one of them would have to be negative. Or you could look at the second variable term. You have negative 4y and positive 8y. One of them's already negative, and they both go into 8. So in this case, it makes more sense to only change the first equation. Again, if you make 5 and 2 into 10x, you'll still get the right answer. It's just easier to only make this first equation change. So you have to ask yourself, what do I have to multiply negative 4 by to get the opposite of 8y? The opposite of 8y we know is negative 8y. You just got to multiply it by 2. So you have to multiply, but not just that one term by 2. You have to multiply the whole equation. So 2 times 5x is 10x. 2 times negative 4y is negative 8y. And 2 times 3 is positive 6. So now when we look at it, if you ignore the top equation because we just converted it, now you're looking at two equations in a system that are stacked correctly that have opposite coefficients, 8 and negative 8y. Combine the rest of them. 2x and 10x is 12x. 8 and negative 8y cancel out, equals negative 2 and 6 is positive 4. 12x is what it should have said. So now all you have to do is solve for x. Divide by 12. Do the same here. X's value equals 4 over 12. The number 4 goes into both of them. It goes into itself once and into 12 3 times. So you have a value for x. It equals 1/3. Again, it doesn't matter which equation you plug 1/3 into. If I plug it into the top equation, 5 times x, or 5 times 1/3, minus 4 times y equals 3. Multiply straight across. 5 times 1 is 5. 1 times 3 is 3. Minus 4y equals 3. Not minus 4 over y. Minus 4y. Get rid of positive 5 over 3 by subtracting 5 over 3 on both sides. So now you have negative 4y equals 3 minus 5 over 3, or minus 1 2/3. So what that leaves you with is positive 1 1/3. And everybody hates to do fractions. You're not alone on that. So 3 times 1 is 3, plus 1 is 4. So what you have is negative 4y equals 4 over 3. Just made it back into an improper fraction. And then get rid of negative 4 times something by dividing by negative 4. Divide this side by negative 4, which is over 1. And remember, anytime you divide fractions, you multiply by the reciprocal. So what you're left with, another way on the edge of the page, is 4 over 3 times negative 1 over 4. Notice I used the reciprocal and I flipped it since I changed it from division to multiplication. Multiply straight across. 4 times negative 1 is negative 4. 3 times 4 is 12. And again, the number 4 goes into both of them. It goes into itself negative 1 time and into 12 3 times. So your value for y is negative 1/3. So x comma y, positive 1/3, comma, negative 1/3. And if you use decimals, you'd be dealing with 0.33 in this case. Example, here's the checkpoint. It says, use the linear combinations to solve the system. This one's nice and neat for us. X is on top of x's. We have opposites, 4 and negative 4. So when we put those two together, they eliminate, they cancel. You have to put y, if you have to draw the 1 in there, then do it. 1y and 2y together, and you get 3y. And then put negative 4 and positive 16 together and get 12. Get rid of 3 times y by dividing it. Do it here. Y equals 4. Notice how much faster this method is when it's set up nicely for you. Plug that one into either equation. I'll plug it into the first one. 4x plus y's value is now 4. equals negative 4. 4 times x, you get rid of plus 4 by subtracting it. Do it here. 4x equals negative 8. And then get rid of 4 times something by dividing it here. And you get, we'll come back to the answers in just a second, but you get x's value as negative 2. X comma y, negative 2 comma 4. X comma y. For the other one, do the same thing, but instead of having opposite terms already, they're already stacked, but you don't have opposite terms already. So you can use 7 and 5 and get to their first term that they share in common, which is 35. We would make this equation much bigger. Or you can say, what about 2 and 1? They both go into the number 2. That bottom equation already has 2, so leave it alone. Don't change it at all if you don't have to. So you ask yourself, what do I multiply this top equation by to get 1y to become the opposite of 2y? The opposite of 2y we know is negative 2y. So multiply that by negative 2. But again, you can't just multiply that one term. You have to distribute it to every term. Negative 2 times 7x is negative 14x. Negative 2 times 1y is minus 2y, or negative 2y. And negative 2 times 2 is negative 4. Once you have that, you can combine them in order to eliminate. 5x and negative 14x combined is going to be negative 9x. 2y and negative 2y eliminates. And then 4 and negative 4 is going to be 0. They eliminate each other as well. We're going to put in 0 as a placeholder. So what you have is negative 9x equals 0. Get rid of negative 9 times something by dividing it. 0 divided by anything is going to be 0. So plug that value in order to find out what the y value is. 7 times your new value of x is 0 plus y equals 2. X 0 times anything is nothing. It eliminates itself. Y equals 2 is what you're left with. X comma y 0 comma 2. And then example number 3 says solve the linear system. Now notice what's going on with this one. X's and Y's are not on top of each other. You have to rearrange one of the equations. The example chose to rearrange the first equation. It says 3y equals negative 6 minus 4x. So you want to move minus or negative 4x over to the other side. If it was negative on the right, when it moves over, notice it becomes positive 4x. So you have positive 4x, positive 3y equals negative 6. That's the only change that was made. The negative 4x was brought over. Now you have x's on top of x's, y's on top of y's, constants on top of constants. You need to make opposite terms. You either need to make opposites out of 4 and 7, which you're going to get all the way to the number 28 if you do that, or make opposites out of 3 and 3. You already have them as the same number. Now let's just make one of them opposite. So it multiplies, it chose to multiply the second equation by negative 1. Multiply the whole thing by negative 1. Again, you have to distribute. Negative 1 times 7x is negative 7x. Negative 1 times positive 3y is negative 3y, and negative 1 times negative 15 becomes positive 15. So now in this step here, you have opposite terms, 3y and negative 3y. We can combine them in order to eliminate them. 4 and negative 7x combines to give you negative 3x. 3y and negative 3y combines to give you no y's. And then negative 6 and positive 15 gives you 9. So you have negative 3x equals 9. Divide by negative 3x to get x equals negative 3. So once you have your value for x, plug it in order to find your value for y. Chose the second equation. Instead of 7x plus 3y equals negative 15, 7 times negative 3 plus 3y. 7 times negative 3 we know is negative 21. Plus 3y equals negative 15. Get rid of negative 21 by adding it. When you add 21 to both sides, we have, they always leave that step off. Plus 3y equals negative 15. Add 21 to both sides. and you get 3y equals positive 6, and then divide by 3 on both sides. So you get y's value as 2. So you have x at negative 3, y at 2, x comma y negative 3 comma 2. Copy this one out in the margin real quick. Again, follow the same steps. Reorder one of the equations to make a match, and then make sure you have an opposite term that you can eliminate.